OSHA does not have specific regulations addressing arc flash protection procedures for panel boards with the outer panel cover removed and the dead front cover in place. However, the following guidance and resources may be helpful. NFPA 70E, which stands for National Fire Protection Association Standard for Electrical Safety in the Workplace, provides guidance on electrical safety, including arc flash hazards. While it does not directly address the specific question of working with the outer panel cover removed but the dead front cover in place, it may provide general insights on arc flash protection. IEEE 1584 provides methods for calculating arc flash hazards and assessing the need for personal protective equipment, or PPE. It may help determine if arc flash procedures are necessary for the specific panel board configuration. It is also important to consult the manufacturer's instructions for the specific panel board. They may provide guidance on arc flash hazards and recommended safety procedures. It is recommended to perform an arc flash assessment to evaluate the potential hazards and determine the appropriate PPE and safety procedures. This should be conducted by a qualified electrical engineer or a licensed electrician familiar with arc flash hazards. As a general guideline, it is prudent to assume that there is potential for arc flash hazards when working on energized electrical equipment, even if the dead front cover is in place. It is recommended to follow established safety procedures, including wearing appropriate PPE and following safe work practices. Here is some additional information you might find useful. NFPA 70E provides detailed guidance on electrical safety in the workplace. This standard outlines requirements for safe work practices, PPE, and other measures to protect employees from electrical hazards, including arc flash. IEEE 1584 offers a guide for performing arc flash hazard calculations. This standard provides methods for determining the incident energy and arc flash boundary for various electrical equipment configurations. The calculations can help assess the severity of the arc flash hazard and determine the appropriate PPE requirements. When working on or near electrical equipment, it is essential to follow safe work practices to minimize the risk of arc flash injuries. These practices may include energizing equipment before working on it, using insulated tools and equipment, maintaining a safe working distance, and wearing appropriate PPE. PPE is crucial for protecting workers from arc flash hazards. The type of PPE required will depend on the severity of the potential arc flash hazard. Common types of PPE include arc-rated clothing, face shields, safety glasses, gloves, and footwear. Arc flash assessments are conducted to evaluate the potential arc flash hazards in a specific workplace or electrical system. These assessments typically involve collecting data on the electrical equipment, performing arc flash calculations, and identifying potential hazards. The results of the arc flash assessment can be used to develop safety procedures and determine the appropriate PPE requirements. Qualified electrical workers are individuals who have the skills and knowledge to safely work on or near electrical equipment. These workers should be trained in arc flash safety and qualified to perform specific electrical tasks. Training should include information on arc flash hazards, safe work practices, PPE requirements, and emergency procedures. Electrical safety programs are comprehensive plans that outline the policies, procedures, and training requirements for electrical safety in the workplace. These programs should be developed in accordance with applicable standards and regulations. Regular audits should be conducted to ensure that the electrical safety program is effective and up to date. Electrical safety audits are systematic reviews of an electrical system or workplace to identify potential hazards and ensure compliance with safety standards. These audits should be conducted by qualified individuals and should include a review of electrical equipment, work practices, and training programs. The results of the audit should be used to develop corrective actions to address any identified hazards. Lockout/tagout procedures are used to energize electrical equipment before working on it. These procedures involve disconnecting the equipment from its power source and securing it in a safe position. Lockout/tagout procedures should be followed whenever possible to prevent accidental energization of equipment during maintenance or repair work. Grounding is the process of connecting electrical equipment to the earth to provide a path for fault current to flow. Grounding helps to protect workers from electric shock hazards. Grounding systems should be properly designed and maintained to ensure their effectiveness. Electrical insulation is used to prevent electrical current from flowing through unintended paths. Insulation material should be selected based on their voltage rating and environmental conditions. Regular inspections should be conducted to ensure that insulation is in good condition and free from damage. Arc flash is a dangerous phenomenon that can occur when electrical current flows through the air between two conductors. Arc flash events can generate extremely high temperatures and pressures, which can cause severe burns, injuries, and even death. Arc flash hazards are present in many workplaces where electrical equipment is used. It is important to take steps to minimize the risk of arc flash injuries. Circuit breakers are designed to protect electrical circuits from overloads and short circuits. Circuit breakers should be properly sized and maintained to ensure that they function properly. Regular testing should be conducted to verify that circuit breakers are operating within their specified parameters. Fuses are another type of overcurrent protection device. Fuses are designed to melt and interrupt the flow of current when an overload or short circuit occurs. Fuses should be properly sized and maintained to ensure that they function properly. Regular inspections should be conducted to verify that fuses are in good condition and have not been damaged. Electrical panels are enclosures that house circuit breakers, fuses, and other electrical components. Electrical panels should be properly labeled to identify the circuits that they serve. Electrical panels should be kept clean and free from obstructions. Transformers are used to step up or step down voltage levels in electrical systems. Transformers should be properly sized and maintained to ensure that they operate efficiently and reliably. Regular inspections should be conducted to verify that transformers are in good condition and are not overheating. Motors are used to convert electrical energy into mechanical energy. Motors should be properly sized and maintained to ensure that they operate efficiently and reliably. Regular inspections should be conducted to verify that motors are in good condition and are not overheating. Wiring is used to connect electrical components together. Wiring should be properly sized and installed to ensure that it can safely carry the intended current. Regular inspection should be conducted to verify that wiring is in good condition and is not damaged. Electrical equipment should be inspected regularly to identify potential hazards. Inspections should be conducted by qualified individuals and should include a review of electrical equipment, wiring, and grounding systems. The results of the inspection should be used to develop corrective actions to address any identified hazards. Electrical equipment should be maintained regularly to ensure that it operates safely and reliably. Maintenance activities may include cleaning, lubricating, and repairing or replacing damaged components. Maintenance should be performed by qualified individuals in accordance with manufacturer's instructions. Electrical safety training should be provided to all employees who work on or near electrical equipment. Training should include information on arc flash hazards, safe work practices, PPE requirements, and emergency procedures. Training should be provided on a regular basis to ensure that employees are up to date on the latest safety information. Emergency procedures should be established for responding to electrical emergencies, such as arc flash events or electrical shocks. Emergency procedures should include instructions on how to shut off power, provide first aid, and contact emergency services. Emergency procedures should be communicated to all employees and should be practiced regularly. It is important to remember that electrical safety is everyone's responsibility. By following safe work practices, wearing appropriate PPE, and being aware of potential hazards, we can all help to prevent electrical injuries and fatalities. Working on electrical equipment requires careful consideration and adherence to safety protocols. Firstly, always to energize the circuit whenever possible. This eliminates the risk of electric shock and arc flash. Use lockout/tagout procedures to ensure the circuit remains energized while you are working on it. Secondly, if you must work on energized equipment, use appropriate personal protective equipment. This includes arc-rated clothing, gloves, and face shield. The level of protection required depends on the potential arc flash hazard. Thirdly, maintain a safe working distance from energized parts. This distance is determined by the voltage level and the potential arc flash hazard. Use insulated tools to prevent accidental contact with energized parts. Fourthly, be aware of your surroundings. Ensure that there are no conductive materials or liquids nearby that could create a short circuit. Keep the work area clean and dry. Fifthly, follow established safety procedures. These procedures are designed to minimize the risk of electrical hazards. Consult with a qualified electrical worker if you have any questions or concerns. Sixthly, perform a risk assessment before starting any electrical work. This assessment will help you identify potential hazards and determine the appropriate safety precautions. Seventhly, use properly rated test equipment to verify that circuits are de-energized before working on them. Do not rely solely on the circuit breaker or disconnect switch to de-energize the circuit. Eighthly, never work alone on electrical equipment. Having another person present can provide assistance in case of an emergency. Ninthly, be aware of the limitations of your training and experience. If you are not qualified to perform a particular electrical task, seek assistance from a qualified electrical worker. Tenthly, document all electrical work that you perform. This documentation will help ensure that the work is done correctly and that future maintenance can be performed safely. Always prioritize safety when working with electricity. Electrical hazards can be deadly, so it is essential to take all necessary precautions to protect yourself and others. When dealing with 120/208 volts or 277/480 volt panel boards with the outer panel cover removed but the dead front cover in place, the potential for arc flash hazard still exists. The dead front cover provides a degree of protection, but it does not eliminate the risk entirely. Firstly, an arc flash can occur if there is a fault or short circuit behind the dead front cover. Secondly, the dead front cover may not be properly installed or maintained, leaving gaps or openings that could allow an arc flash to escape. Thirdly, the dead front cover may be damaged or deteriorated, reducing its effectiveness. Fourthly, even if the dead front cover is intact, an arc flash can still occur if a tool or other conductive object accidentally contacts an energized part. Fifthly, the severity of an arc flash depends on several factors, including the voltage level, the available fault current, and the distance from the arc. Sixthly, a 120/208 volt or 277/480 volt panelboard can still produce a significant arc flash hazard, even with the dead front cover in place. Seventhly, it is important to perform an arc flash assessment to determine the potential hazards and the appropriate safety precautions. Eighthly, the arc flash assessment should consider the specific panelboard configuration, the operating conditions, and the qualifications of the personnel performing the work. Ninthly, based on the arc flash assessment, appropriate PPE and safe work practices should be implemented. Tenthly, PPE may include arc-rated clothing, gloves, face shield, and hearing protection. Safe work practices may include de-energizing the equipment, using insulated tools, and maintaining a safe working distance. Remember, even with the dead front cover in place, it is prudent to treat energized electrical equipment with caution and to follow established safety procedures to minimize the risk of arc flash injuries. The location provided, Roxbury, Connecticut, does not change the general safety advice regarding arc flash protection. The principles and guidelines outlined previously apply regardless of the specific location.